There are so many varied objects in our surrounding environment. For the sake of convenience, we can divide science into various disciplines: chemistry, physics, biology, etc. Chemistry is the branch of science which deals with the study of composition, structure, and properties of matter, and changes which matter undergoes under different conditions. Chemistry has a reputation for being a complicated and boring science, but for the most part, that reputation is undeserved. Fireworks and explosions are based on chemistry, so it's definitely not a boring science. Even your body is made of chemicals. Chemical reactions occur when you breathe, eat, or just sit there reading. All matter is made of chemicals, so the importance of chemistry is that it's the study of everything. The gas and tires in cars we drive, the makeup we put on our faces, the soaps and cleaners used every day, burning wood or other fossil fuels. Chemistry is all around you each and every day. The associations are practically limitless. So, as you go about your daily activities, remember to thank chemistry. Chemistry is at the heart of environmental issues. What makes one chemical a nutrient and another chemical a pollutant? How can you clean up the environment? What processes can produce the things you need without harming the environment? Chemistry is important in agriculture. It is very important in the production of fertilizers, pesticides, preservatives, etc. Also, many of the life-saving drugs and other medicines are being prepared by chemists. Life-saving drugs such as cisplatin and Taxol are effective in cancer therapy. With better understanding of chemical principles, we can now design and synthesize new materials having specific properties. We're all chemists. We use chemicals every day and perform chemical reactions without thinking much about them. Chemistry is important because everything you do is chemistry. Nature of matter. Everything which has mass and occupies space is called matter. Everything around us, the air we breathe, the water that we drink, the books we read, the car that we drive, everything is made of matter. Atoms are the basic building blocks of matter that make up everyday objects. We know that matter can be classified into three physical states: solid, liquid, and gas. Let us take the example of water to learn more about these three states of matter. Water in solid state is called as ice. As you can see, the constituent particles are held close to each other in an orderly manner. Because of this, solids have definite shape and volume. When water is in the liquid state, the particles are still close to each other, but they can move around. Because of this, liquids have definite volume, but no definite shape, and so they take the shape of the container in which they are kept. When water is in the vapor form, the particles are far apart as compared to those present in solid or liquid states, and their movement is also quite free and fast. Because of this, the gases have no definite shape or volume, and they completely occupy all space that is available to them. As we saw, all these states of matter were interconvertible by changing the conditions of temperature and pressure. Heating can change a substance from solid to liquid to gas, while the cooling process will achieve the reverse effect. We can broadly classify matter as mixtures or pure substances. When any substance is made up of only one kind of component, it is called a pure substance. For example, the graphite in the pencil that we use to write is made up of only carbon atoms. Hence, it is a pure substance. Such substances which have only one type of atoms are called as elements. But different elements have different atoms. For example, an atom of sodium is different from an atom of oxygen. The water that we drink is made up of only water molecules, so it is also a pure substance. In all water molecules, 2 atoms of hydrogen and 1 atom of oxygen is present. Thus, they are always in a fixed ratio. All elements and compounds are pure substances. Also, the properties of the compound are usually different from its constituent elements. Like as we saw, water is a liquid, but its constituent elements, hydrogen and oxygen, as we know, are gases. Also, hydrogen burns easily, while oxygen supports combustion on the other hand. Water is used as a fire extinguisher. Some substances are made up of more than one substance, which can be in any ratio. They are called as mixtures. For example, air has molecules of nitrogen, oxygen, water, carbon dioxide, etc. But these components are not easily distinguishable. Hence, it is a homogeneous mixture. While in some mixtures, it is easy to separate out the components. For example, the stones that can be easily picked out from the mixture of grains and pulses. Also, when you pour oil in water, they form separate layers. Both of them are examples of heterogeneous mixtures, as the composition of components is not uniform, and the different components can be easily observed. There are only 2 kinds of pure substances, elements and compounds. When any substance is made up of only one kind of component, it is called a pure substance. Thus, elements and compounds are considered to be pure substances. It has the same color, taste, texture, and composition. Also, it is made out of a same particle. Elements are the simplest form of matter and cannot be broken down using chemical methods into 2 or more pure substances. For example, iron is a pure substance. You can take a piece of iron and break it down into smaller and smaller pieces, but each of these smaller pieces has the same properties as the starting material. Hence, it is always the same substance. Sodium, copper, oxygen, hydrogen, carbon, nitrogen, etc. are some of the examples of elements which contain atoms of only one type. Compounds, on the other hand, can be broken down into 2 or more pure substances. For example, H2O or water can be broken down into H2, hydrogen gas, and O2, oxygen gas. The examples of some compounds are water, ammonia, carbon dioxide, etc. Observe that a water molecule comprises 2 hydrogen atoms and 1 oxygen atom, and a molecule of carbon dioxide contains 2 oxygen atoms and 1 carbon atom. Thus, the atoms of different elements are present in a compound in a fixed and definite ratio, and this ratio is characteristic of a particular compound.